Hi folks, well welcome back to another lesson, and today we're going to look at Ohm's law, which you probably remember is the following equation: V is equal to IR. Voltage is in volts as always, although we should really start calling it potential difference rather than voltage. I'm quite bad because I'm so used to using voltage, but the correct term is actually potential difference, or P dot D. Okay, so let's try and stick to using potential difference. Okay, so current is in amps as always, and resistance is in ohms. And there's a wee picture of Georg Ohm, who invented this law. Really, really important, because when we did this, we came across this graph of if you plot V against I, you get a nice straight line going through the origin, which if you remember, the resistance is the gradient of the graph. So if you work out the gradient of this graph, take any 2 points on the straight line, preferably as far apart as possible. Use your equation for the gradient of a straight line from maths: y2 minus y1 over x2 minus x2. We then get the resistance, which is also the gradient of the graph. Okay. The other thing to remember is that from this graph, because it's a straight line through the origin, we say that V is proportional to I, and that's what this wee alpha symbol means in maths. It means it's proportional, and what that means is if you double one quantity, the other will double by the same amount. So if we doubled the voltage, the current would double by the same amount. Don't worry too much about how we derive the equation from that proportionality relationship. The key thing here is that you're able to tell me the relationship is proportional. If it was just a straight line going through the y-axis or the x-axis, it doesn't go through the origin, we call that relationship linear. Okay, now I'm going through that again because we're going to use these concepts of proportional and linear in your higher assignment coursework, which will take place later in the year. Okay, so what you did in Nat 5 is really important in higher as well. Okay. So today's main lesson is we're going to apply Ohm's law to combination circuits which look like this, right? And we're going to be working out what the voltages and currents are in various parts of the circuits. Now, it's quite tricky to try and analyze something like this. So the trick here is that we always want to simplify the circuit until it just has one resistor and a battery. Okay, so that's what we're always aiming for. And if you think back to the previous lesson when I asked you to always sketch the circuit, that's the reason why, because then you can keep track of all the changes that are happening. So we're going to use that skill again. So this is why I keep saying to practice what I show you, because it's how I want you to process these problems. You can, of course, do it your own way, but if you get stuck, it gets harder for you to troubleshoot. Okay, now you'll probably remember this, but these are some of the equations from the electricity topic, and these are the ones that we're going to focus on today, right? We assume you know how to use these equations, and we're going to come back to these when we do AC and DC in greater depth. This one is a very common one that people always forget. Charge is equal to current times time. We're going to come back to this when we do capacitors. Power is equal to energy over time. We'll be using that when we do conservation of energy again. So although it's Nat 5 content, and we usually don't examine Nat 5 and higher, we do assume you've got these as your kind of basic knowledge, and you will need them to problem solve the much more trickier examples. So please make sure you're familiar with these, and when we come to use them, you won't be too shocked by it, basically. Okay, so let's get stuck into numerical examples. The best way I can think of to show you how to do these is, to be honest with you, you've got all the theory, you've got all the rules. That's what we've been working towards for the last couple of lessons. The best thing to do now is just to do as many worked examples as possible and just get experience on how to apply these rules. The only way to get good at doing these questions is practice, practice. Because if you make a mistake, you learn from that mistake and you won't make it again, hopefully. Okay? So the rest of this lesson, there's about maybe 4 or 5 examples, maybe even more. They are a mixture of examples that I've made up or past paper question examples taken from the Nat 5 exam. So for me, if you're confident with this and you're happy with how to do it, sip on to the next slide and see if it's something that you think you can do. Try it. Don't just look at it and say, oh, I can do that, no problem, I've seen it before. Actually do it so that way you can see you actually have the right answer. Okay? Right? Practice, practice makes perfect. The more effort you put into this, the easier it will become, the easier it will be for your higher course. Okay? So how do we solve this one? So let's look at the answer. So before we get to that one, I'll come back to that previous example. Let's do a slightly simpler one to ease our way into this. And I want to show you the basic method. This part of the course is actually really easy because there's a set method for you to follow. If you follow that method every time, you should be able to get the answer. Okay? So example 1, which resistor has the biggest current? Calculate the voltages for R1 and R2. If you want, pause the video and just try this yourself. If you're not sure, just listen in, but feel free to pause at any time to have a go at yourself. So 10 seconds, which resistor has the biggest current? Okay, hopefully you got the answer is that the current's the same for both resistors, because what's the rule for current in series? It's constant. Okay, so it's a trick question. Both these resistors have the same current going through them. What are the voltages across R1 and R2? Well, there's lots of ways we can do this. There's something called voltage dividers, which we'll come back to later on. We did it in Nat 5, we do it again higher, so we're not going to do that. Some of you might remember it. We're going to do it instead by looking at Ohm's law. Okay, so first of all, we can see we know the supply voltage, we know the resistances, so we know it. We know we've got Vs, R1 and R2. Normally I would write these down the side here, but I'm not because I know it's going to take me too long to do it on the boards. Okay, but please you do it yourselves. Now the trick, remember, is this is a slightly complicated circuit because it's got two things in series. So we're going to try and convert it into the simplest circuit, which is this one here. Okay, so step 1 of my method is always simplify your circuit until you get this thing here. That is the step 1, the most crucial one. Okay, so let's just label this. We know there's 15 volts here. 5 plus 15 is just 20, so 20 ohms there. Now, why have I got this circuit here now? Because we've only got one resistance and one voltage, so we can apply Ohm's law. And we can apply Ohm's law to give us a current, which is V over R. Okay, so nice and straightforward. Remember, 1 mark for writing down the equation. A wee exam technique here. When you're writing down the equation, write it in the form it gives you in the equation sheet. I know I've jumped ahead a wee bit and written I is equal to V over R. But if you make a mistake at this point where you rearrange the equation, okay, so say here I wrote down I is equal to V times R, that's wrong physics, you get 0 marks. Whereas if I write this down here, I would get 1 mark straight away. But if I rearranged it wrong, okay, I would lose a mark, but that's a mathematical mistake. It's not wrong physics because I've already shown I know the physics. So there, I would lose 1 mark, and provided I was consistent and carried it through, I could still pick up that final mark. So the difference is getting 0 marks or 2 out of 3. In other words, you could pass with a B or you could fail. Okay, so that's why exam technique is really, really important. Anyhow, back to the problem. We've got 15 divided by 20, which if you do on your calculator, gives you an answer of 0.75 amps. Okay, and remember your units, although it's not important here because we're not asked for that. But the question could ask you, what's the current in the circuit? Well, the answer would be 0.75 amps. Now, here's the really nice bit. If you draw the diagram, you can label it on here, and you can label it on the diagram there. Now, if we think about it, this is a series circuit. We know it's 0.75 amps. So what's the current through this circuit here at any point? It must be 0.75 amps. What's the current through R1? 0.75 amps. What's the current through R2? 0.75 amps. So what we can now do is we can do V1 is equal to I times R1, because we know that for that resistor, the current is going to be 0.75. We can do the same. V2 is equal to I, the same current, because it's constant, times R2. Okay, now I'm going to skip ahead and give you the answer because I don't want you to get too bored waiting for me to tell you the exam technique. You should be doing that off the top of your head by now. But V1 is equal to 0.75 times 5. So the answer is 3.75 volts. Right? Remember that units because that gives you the final mark along with your correct answer. V2 is 0.75 times 15, which is 11.25 volts. Now, as a final point, how do I know these two answers are actually correct? And this is what I really love about electricity. It all fits together. Well, remember our rule about voltages in series. What's the rule? Voltages will split up according to the number of components and the resistances in a circuit. So if I add these two voltages together, I should get the supply voltage again. So 11.25 plus 11.25 plus 3.75, and I get 15 volts. So I know my answer is correct because my individual voltages add back up to the supply voltage. And that's the nice thing about physics, is you can always check the answer because it's consistent. Okay, folks? Right, now this example here is actually a past paper question. Notice that it's actually out of 4 marks and not 3. Okay, so let's try this one here. As always, if you want to try it yourself, pause the video. So it says, a student is investigating connecting different combinations of resistors in circuits. The student sets up a circuit as shown. Okay, calculate the current in the circuit. Now, a wee point, folks, they haven't labelled these resistors, so it's up to you to call them R1, R2, and R3. Okay, again, I'm missing out the R to make it easier for me, but pretty straightforward. It's a series circuit, so we want to make it into the simplest circuit possible, which is this one here. Okay, so there it's 180 plus 180 plus 120, which is, off the top of my head, I think is 180 plus 180, let's do it in the calculator, 480 ohms. Okay, so then we know it's 12 volts, and because it's the simplest circuit already, we just use Ohm's law. So remember, write down your equation as you see it in the equation sheet. So you pick up marks, easy marks. V is equal to IR. So I is now, at a wee point, I would actually plug in the numbers first before rearranging it. It's exam technique because, again, if you plug in the numbers, you're picking up marks. So if I wrote this down next, I would be getting at least 2 out of 4 marks. In fact, I'd be sitting at 3 because I would have got a mark for calculating this, and then I would have got a mark for writing this down, and then a mark for writing this down, and then finally, if I do 480 divided by, 12 divided by 480, and I get the answer 0.025 amps. And I get a final mark for getting this bit here with the correct units. Okay, so again, what I want to take away from this is the process. Okay, figured out if it was series or parallel, simplified it to the simplest circuit, which is this thing here, worked out whatever it was that I needed to work out, whether it was a voltage or a current. Then I went back the way to say, well, if I know the current, then I must know the current here because it's in series, and that obviously gave me the answer. But if I wanted to, I could work out the voltage across each of these now because I know the resistance and the current passing through each resistor. So that's the process. Learn it and you'll become experts at these. Okay, so let's get back to that example I showed you before. Calculate the currents and voltages for R1, R2 and R3. Okay, as always, if you want to try it yourself, then do so. Now, this one's a wee bit trickier because notice we've got a wee bit in parallel and then a wee bit in series. So we can't jump straight away to our simplest circuit. We've got to get rid of the parallel bit first, which means we're going to have this as our next stage of the circuit. Okay, so let's do this very quickly. 1 over 6 plus 1 over 3 is a half. Remember to flip the answer. So there we have 2 ohms and 10 ohms. Now, obviously, I would expect you to write out all your working. Here, I'm just skipping on that because it's a pain for me to do it on this kind of PowerPoint slide. If I was doing it on the board, I would definitely write it up for you. And then notice how we've now got 2 resistors in series. So then we can sip on to our simplest circuit, which is this one here. Okay, and 10 plus 2 is simply 12 ohms. So we know the 12 ohms there, and there's 12 volts there. Okay, notice one thing that I haven't skimped upon is that I've actually sketched each circuit as we've gone along because it really helps you to keep track of what's happening. Okay, so final bit is work out the current. Well, we know it's 12 volts and 12 ohms. V is equal to IR. I is 12 over 12, V over R. So we know there is 1 amp going through the circuit here. Okay, again, go through the working yourselves. I'm just trying to take you through it very quickly. So if we know there's 1 amp here, there must be 1 amp here. There must also be 1 amp going through here. Okay. Now, this is where you do have to be a wee bit flexible to try and figure out what's happening, right? If I jump from this circuit here to here, there's too much happening in that first circuit for me to work out everything. So I go back to my intermediate circuit, this one here, and I say to myself, well, it's a series circuit. I know there's 1 amp going through it. What's the other thing I could work out? Well, I know it's still 12 volt supply. So the only thing missing here are V1 and this V here, isn't it? Okay, normally if I'm changing this, I should really say that earlier, this is now R4, okay, because it is technically a different resistor, and this is now R5, okay? So how do I work out the voltage across R4? Well, we're using the same old equation, Ohm's law, V equal to IR. Okay, I'll write it out just now because you've not seen this bit before. So it would be 1 times 4, which is 4 volts. Okay, nice and simple. We're just using our series circuit rules and Ohm's law. Now we can use a wee trick here. because we could do the same process, V equal to IR, to work out the voltage here, but we know that the total voltage must equal to 12. So if there's 4 here, then there must be 8 here, because 4 plus 8 gives us 12 volts. Okay, so we can then transfer this to the other side, because we now know this is 8 volts with 1 amp going through it. We know there's a total of 4 volts across R4, so that means there must be 4 volts going across both of these, because they're actually in parallel. Okay, so notice how I carried my answers back the way to help me work out what was happening in the original circuit. And notice how I'm also applying my circuit rules. This slide is worth reviewing again, because these are the type of questions you're going to get in your exams. Okay, so talking about exam questions, here's one here. So it says a student sets up the following circuits. The student closes switch S1, calculate the voltage across the motor. So if switch S1 is closed, let's add that in. We know that this is open, so we can ignore this, because if it's open, there's no current flowing. So this is actually a series circuit. So remember, we want to put it into the simplest form, the simplest circuit, but because it's a series circuit, we know straight away we can jump to this one here. So this is 12 volts. Okay, that's 15 plus 25, which is 40. Okay, and then from there, we're back to our good old friend, the simplest circuit. So current would just be 12 over 40, which means it's 0.3 amps. Okay, and then we want the voltage across the motor, but we know there's 0.3 amps going through that circuit, because there's 0.3 amps going through this one. So therefore, voltage is V equal to IR. So it would be 0.3 times 25, which gives us 7.5 volts. And that's the answer there, and that was worth 4 marks. Okay. Now, you might say, well, if that's 7.5 volts, then that means this must be 4.5 volts across here. And we could check that, because we know the 0.3 amps going through there. So multiply that by 15 gives us 4.5. So we know we're correct. Nice and straightforward, folks. Okay. Again, notice the procedure that I'm following. Okay, so let's switch things around a wee bit. Example number 4. What is the required polarity of A and B when connected to a 5-volt supply so that the LED emits light? What's the purpose of the resistor R in the circuit? The LED rating is 10 milliamps at 2 volts. Calculate the value of the resistor. Now, this example is actually a higher question. Okay, it's part of a higher assessment, in fact. So make sure you know this one well. Okay, so first of all, what's the required polarity? Well, from that 5, we know that this is an LED, and LEDs only work if you connect them in with the correct polarity. Now, by polarity, I mean the positive or negative terminal. Okay, so for this to work, it will only work if B is negative and A, pardon me, is positive. Okay, the way I always remember that is that the line here should always match up with the negative one. Okay, later on in the higher course, we're going to explain how you actually make an LED and why it is that it's actually going to be connected this way around. Okay, there's some really good physics there. I'm sure you're going to love it, folks. Okay, so that's the first answer. That's going to be negative, that's going to be positive. What's the purpose of the resistor in the circuit? It's to protect the LED. Okay, what it does is it reduces the current so that you don't overload this with a high current and you damage the LEDs. LEDs are brilliant devices because they only use very, very small currents. Okay. Final bit, the LED rating is 10 milliamps at 2 volts. calculate the value of the resistor. So there's a wee bit of thinking involved here. We're told that, first of all, know it. So know it means we know there are 2 volts across the LED, and we know that supply voltage is 5 volts. Okay, we know there are 10 amps going through the circuit, or 10 milliamps, sorry, not 10 amps. Okay, so notice how I am filling in the information onto my circuit. Now, 10 milliamps, you should be familiar with this. The small m stands for milli, which is the same as saying 10 times 10 to the minus 3. So if I write this out in full, you can see what I mean. Now, usually what I do is I start the course with a wee bit of numeracy, but because of the lockdown, I've started off with electricity. We will come back to the numeracy later on again, which seems a bit backwards. So we know there's 10 milliamps, it's a series circuit, so there must be 10 milliamps going through the resistor. Okay, so that's know it. How can we find the value of the resistor? So R is our unknown, so I usually write down the symbol and a question mark to remind myself what it is I'm trying to find. Okay, we know it's a resistor, so there must be a current going through it, which we know because it's actually in series, so it must be 10 milliamps, or 10 times 10 to the minus 3. Okay, so here I'm doing my know it again. And then finally, what's the voltage across this resistor? Well, look at your circuit. We've got supply voltage of 5, we've got 2 across the LED, so that means there must be 3 volts across the resistor. And then we find it, so we find the equation, which is just simply Ohm's law. Okay, so this is where we pick up a mark. You would probably get a mark for doing this bit, because obviously we don't give it to you, so that's 1 mark. This would be your second mark. Then you plug in your numbers. 3 is equal to 10. Now notice how I've not rearranged the equation, I've just put my numbers in, and that's what I recommend you do, because by doing this, I'm picking up my 3rd out of 4 marks. Okay, so that's another mark there. And then the final mark is just for doing the actual numerical bit. Okay, remember this is a physics exam, not a maths exam, so that's why the majority of the marks is for the physics. And if we do that, folks, we should get the answer of 300 if my maths is correct. Yep. So the answer there is 300 ohms. Okay, make sure you know how to do this type of question because it can come up in your exams or in tests. So this is a very classic example of how to use Ohm's law.